Good morning, everybody. Thanks for joining us today. We are going to be discussing a bit about how you can reduce your operational costs, and really with that system platform solution as the base. There's obviously lots of things we could cover in this, and I'm really only scratching the surface. We'll probably dive into some of these topics in a bit more depth as we go through into later webinars. We're going to have a look at a few of the trends in the market, and then move into a bit about skill set, the demand for skills inside of an organisation, stuff around quality, so that's quality of products, but also whether you're going to be needing to reduce downtime and things like that from a quality perspective. We're then looking at a little bit about regulatory compliance, and there's not an awful lot on here because it's pretty much is what it says on the tin. Then around staying current, so there's always a little bit about legacy, stuff around security that's tied into that, and security is a whole other topic in itself. We're then going to just cover a bit about continuous improvement and a bit about maintenance as well, and then got a Q&A session at the end for any questions. So to start with, if we look at some trends, and certainly from a calculating your operational costs, it's really a matter of adding together basically your raw materials, so everything that is added into a product. Then this is also added to your labour costs, so that's like the salaries of your employees, any benefits they might receive, and then the manufacturing labour costs. So things, this is actually quite time consuming because reason being you could have people that are indirectly related to the process. People like supervisors aren't always there day to day to run that production run, if you like. So it's hard to account for their time and their effort that went into that. There could be materials used for things like maintenance. There's maintenance of machines that you've got to cover to keep the machines running, etc., etc. So there's lots of things. But either way, if you add all these things together, you'll get an overall cost for your manufacturing over whatever period you've chosen that for. If we look at then standard methods for reducing operational costs, you will more than likely have already looked at things like purchasing cheaper raw materials as an example, making cutbacks to reduce overheads. Another common method can be increasing efficiency in your production process, to essentially just increase throughput, improve that bottom line. But it's important you know in what areas to do this, and it's often one of the hardest parts. And you've probably heard us talk about the people, process and technology before in the past, in previous webinars and at events and things, and these are all very key to making these work well. And there's lots of reasons for that, which I'll summarise at the end. There are, however, other ways that we can reduce operational costs, and we're going to go into a bit more detail throughout this webinar. Obviously, we can't cover everything in the time frame we have, but happy to have further discussions following this. One of the big trends that we do see is things like downtime, and there's some quite interesting figures on that screen that you see there. So there's 24% of total manufacturing costs is attributed to downtime, so that's a huge sum. And actually, 300% is the amount by which total downtime cost is usually underestimated. So people don't necessarily associate their downtime cost for whatever reason. It could be the case that we're just not recording it. There might not be an automated system. It might be all paper-based. Might be writing it on whiteboards in the plant floor. It's still extremely common to do it in this way. It's very easy to then miss it, or think, oh, I'll write it later, and then we've forgotten the detail of it, or we haven't noticed that there's been 3 or 4 stoppages in that time and we've only recorded one of them. So it's very difficult to understand your exact amount of downtime that you've had. 90% of the amount of maintenance work carried out is categorised as crisis work, which means that really we're on a break-fix model. We're waiting until something fails. We're not actively looking at the maintenance, or we are looking at the maintenance of machines and we're doing it on a regular cycle, which can also be prohibitive because you could be maintaining something that didn't actually need maintaining, but we don't know that it didn't because we haven't got the data or the analysis to be able to perform that. And then there's $2.5 million is the cost per hour of downtime in automotive manufacturing. So it's just a specific vertical. Obviously, it's quite high cost from an automotive perspective. It's quite high cost, and you'll all have figures that are associated in your industries. Food and bev is likely to be slightly less. Pharmaceuticals probably high up there as well. Then if you look at the manufacturing operations, and I tried to segment this, if you like, as the past, the present and the future, as to just a bit of a brief overview as to how our systems look in these environments. So if you look at the past, we've probably had minimal automation. It's probably going back a few years now. We have lots of automation out there these days. It'd certainly be very manual, little or no data storage. So we wouldn't really be storing things. We might be storing things on paper, and it was a very disjointed environment. Certainly we wouldn't expect to see connections up to the business network. We transfer data, or we might do, but we wouldn't have a direct link to that. If we look at the present, and this is what we see more of these days, and it's certainly more joined up and the much more automated our systems out there today. There's lots of robotics out there that are doing some of the tasks that, like packaging and things. We see lots of that these days. Most, if not all, data is stored from the network. I do say most because there's still elements that we choose not to store. If we do choose to store everything, actually it might not all be meaningful, or we might not be storing the right things to be able to do the correct analysis to be able to reduce those costs. So there is some data analytics normally used when we are storing that data, and there's lots of different variants with that. So it might be just on the plant floor, looking at trends of what's happened over a period of time, so that you can analyze it, and hopefully that you can prevent it from occurring in the future. But in those scenarios, there's often it isn't pushed up to the business system, so there's not always people higher up looking at that data. There are still lots of organisations out there that do store paper or store data manually into paper-based systems, and there's still organisations out there that do it extremely well in terms of analysis and making sure everybody can see it in numerous locations around the plant, and the right people can, so you can make the right decisions to improve your process. And if we look at the future, I say the future, it doesn't mean it isn't possible now, but what we're really referring to here is notifications that people don't have to worry about. People get notifications that are really meaningful to them. I put frictionless there because it's something that is, there's some clever technology behind it that is providing the operator or the user with exactly where it needs to go or exactly where it needs to look. And the way that you can do that is with something like predictive maintenance. So there's some very clever algorithms that run in the background that are associating all of the data that you're storing, and it's providing you with that clever view at the front, and I'll talk more about that later. And the future is obviously about information everywhere, and you've heard that probably all over the place with regards to mobility, having data through the right sort of web-based channels that we've come to expect in our day-to-day lives. We now expect it from our plant data as well, and there's lots of different ways that we can do that too. If we then move into Skillset, and you've probably heard us talk about situational awareness before, so it isn't something new. It isn't something that Wonderware do as a unique selling point. You can design situational awareness into any SCADA solution that you put out there. The difference with the way that Wonderware do this is that this is replicated throughout the entire environment, and they also provide you with large libraries so that you can reduce your engineering effort. You can reduce those operational costs, because actually if you have to go and do something or make changes to the system, some of that engineering work has been done up front for you. And also, for an operational cost, if you look at the time to react from an adverse situation, situational awareness is the way to go with that kind of thing, because you look at the two differences on screen. Screen on the left is your traditional or typical SCADA that we've come to expect from the way that we can just design anything into our SCADA systems at the moment, but the screen on the right actually has exactly the same information in, but we can see exactly where the problem lies. So it's about reaction times then, so if we can react quicker, we can prevent something worse happening, because it's all time-based. As soon as an alarm goes off, the longer we leave it, the more likely you are to see an even worse situation start to develop and occur. There's more to Skillset though, so there's an awful lot around training and a skills gap, if you like. So there's, particularly when people leave organisations, there's an awful lot of skills that tend to leave, skills and knowledge leave with that person. That's where the skills gap comes in. So there's an awful lot of training that goes into running a plant facility or monitoring the SCADA, having a look at it. Often there'll be lots of cases where a systems integrator will have to do training, and then the new people have to sit alongside somebody that's been there for a long time to be able to understand what's going on in detail, and it's a real knowledge transfer to be able to achieve that. If you look particularly at things like the above, like the situational awareness concepts and graphics and the way you design things, training is much easier because we standardize on a similar or same look and feel throughout our entire environment or our entire infrastructure. So that could be just line to line if it's quite a small site. It could be plant to plant if we have multiple buildings, or it could be national or even international. If you share that development environment that you've used in one place across the others, you can transfer people amongst the different sites, and they'll understand how to use that SCADA. Training is much reduced from that. So from an operational perspective, again, you're reducing those costs there. And that really is from that look and feel perspective, so generating the same look and feel. And System Platform is excellent at doing this. System Platform is a great basis to be able to put your standards into the solution. Because of the way that the technology is designed, it allows you to then replicate very easily, and it's also extremely scalable. So if you have to include additional lines or you do a new greenfield site, you can take what you've done at a previous site, move it to another one, and you're reducing everything that goes along with it. So you're reducing the engineering cost because so much of it has been done already. You're reducing your training cost because you could actually take people from the sites that you've already got, move them to that new greenfield site, and they could be up and running very, very quickly. If we then move into a bit about quality, and you might associate quality with manufacturing execution systems, and this is fine because, of course, MES will help with things like the quality of your products produced, how you might go about improving them. It's also great for reducing the amount of waste or rework that you have to do. So there are lots of benefits that you can get from implementing an MES solution. But there is another side to quality, and again, it's through the data storage and the intelligence that goes behind it. So if we store enough data from enough parts of the process, then we can get some real insight into exactly what is going on to be able to improve our root cause analysis. The real benefit here is being able to take corrective actions quickly. I've already mentioned it a little bit, so then you can reduce the downtime or even completely prevent it, prevent spills, prevent that rework or that loss of product. So this can make you much more proactive and therefore reduce those costs quite dramatically. You saw some of those figures earlier on associated with downtime. If we can do that more effectively, and all it takes is having the right tools available to you to be able to achieve that. It does rely on the correct data client tool, if you like, for the purpose that you need, and we do obviously have lots and lots in our portfolio, so it's about choosing the right one to achieve your specific needs. And of course, if you know us well, then you'll know that we're more than happy to talk to you about any of those things and advise on the best route to go with regards to that. I'm going to briefly touch on regulatory compliance. So, and the first part is probably really just start telling you to suck eggs, I suppose. So it's really to adhere to something like this, it's important that we have the data available so that we can provide it on demand for audit purposes, for whatever we might need to. Historically, and this is probably going back quite a number of years, but this would have been done through a paper-based filing system. So you can imagine the length of time it would take if you were asked a question as to where you need to find that data. We now don't really have those problems anymore because we have very fast access to our data. So these things are no longer that much of an issue, being able to produce that data on demand. If we look slightly outside of this, and there's a large cost associated with production mistakes. So this could be something like not meeting the demand of the products you needed to create for an order. So that could be in the food and beverage industry, or it could be flooding in the water industry as an example. So for some reason, the floodgate has failed to automate, and that has obviously there's loads of costs associated with the fees and the admin associated with being able to manage and sort that out. If we also look at something like the pharmaceutical industry, there's lots of legislations that go into this. So as an example, simply a loss of data can mean you cannot ship product out of the door. There's lots of different reasons as to why these fees could apply, and there's lots of easy and simple ways to avoid them, to create those corrective actions like we mentioned previously. Or in some cases, it could just be a slight infrastructure change to improve the uptime of your system. So if it is a case that you are losing data, improve the hardware that it's sitting on, or improve the latency or redundancy that you have in your infrastructure to make sure that you don't have that problem. We then look at staying current, and staying current is a huge one. And legacy systems, there's still very old systems out there, still systems running on Windows NT, Windows 2000, XP, lots of them that exist today. And it's really important to stay current. And there's lots of reasons for this. So one of the big ones that's coming to the forefront at the moment is security. So security has been on people's radars for a good few years. And it's a whole other topic in itself. So to, I suppose, try and sort out security, we would isolate our system. And we thought because it's air-gapped, it is then secure. But we now know that that isn't the case. There's many other ways that you can get into a system, and it might not be malicious. It might be just completely innocent and accidental. But from a legacy system perspective, we really need to get those systems up to date. So it's about your Microsoft updates and then your application updates. And from a Microsoft perspective, it's making sure that when they release a patch or service pack, your vendor or supplier has or it goes through a test procedure, a quality assured tested procedure, to make sure that it will be on a supported version by X number of days. You need to make sure that you can upgrade to that Microsoft patch, and do that by making sure it's checked against the version that you're running. From an application perspective, again, it might be a case that actually running to such a legacy system, we have to upgrade our application so that it's supported on the later Microsoft operating systems. And what's really important with that is how we do it. So what's really important is around the upgrade procedure that you go into. So we've already talked a lot about downtime, and we don't want downtime in our system. We want to keep our systems up and running as much as we can do. And to do that, it's about having the right SCADA vendor in place so that you can start to fail over to thinking like redundant automation servers, while you upgrade one, test that it's worked correctly before you then upgrade the other one. And in a solution, again, this is common with system platform, if you want aware, then you can introduce as many automation servers as you like. You can spread the load. You can fail them over to have one system running the entire plant if you wanted to. Apply a Microsoft update to the one that isn't running, test it to make sure that it's worked, and then roll it over and update the other one. So it's important that we get maximum uptime from our systems. If we then have a look at continuous improvement, and this is quite a big one. It's something that people should adopt, and we have lots of organisations out there that do this extremely well, because our processes should change so that you can constantly improve them. And there's a lot about people, processes, and technology in this element. We, again, need to do this by storing lots of data. So we need to analyze it then to work out where in the process we need to make those improvements. And we should then test those theories based on how we've analysed that data by changing certain thresholds, as an example. And then once you've made that change, you should then analyse how that process behaves, because you're storing all that data before you then start that process all over again. So it might be a case that it goes through lots of different iterations in that process to get it up to a real tightly knitted together process, so you're getting the most out of your system. The easiest way that we can manage that type of solution is with a business process management system. So what this will do is automate the complex business processes that you've got across disparate business applications, different organizations if you wanted to, lots of different people, and it views the business from an end-to-end process perspective. So what it will do is then define and manage how business activities are executed, including any sort of interaction with people. So it could be that you give them a call, or it's simply an email process, or somebody logs into a web portal to then go and action it. And they have to obviously then perform different types of business tasks. It could be simple, it could be complex. But it also means you can measure your business performance from an end-to-end perspective. So this means what you can really do is, when I talked about that bit at the beginning around changing your process, testing your theory, analysing those changes, then starting all over again, it means you can now digitally track them inside of a business process management solution, so that you can read back over them and make sure what you've done has worked correctly, or if it hasn't, then you can put some notes against it as to why it hasn't. It's important to have that bit in the middle. So then if we lastly then move on to maintenance, and you could argue maintenance as elements around running the system in a redundant setup, that this is important, and it is, because if you think you want to go through maintenance, it might be maintenance of your software. So if it is the case, then you need to fail over and make sure you're going to be running on a single server while you maintain and update the other server. But really, what we're referring to here in terms of maintenance is in a prognostic type of way. So this is with the devices that sit on your plant floor. So what we're really looking at is very clever ways of analysing probably different data from your systems. It might not be data that's coming straight from your PLC. You might have to add additional sensors to pull that out, because if you don't have things like temperature sensors or vibration sensors, it's very difficult for maintenance applications to be able to achieve that. So we've partnered with a company to be able to deliver that, and it connects directly into our historian through whatever methods that we use, through our APIs if you want to do it through the cloud, or directly to SQL. And really what they're looking at is really through diagnostics and condition monitoring. So it will spot anomalies inside of the system so that you can be more proactive, essentially, as a means, and it reduces that downtime by a dramatic amount because of this. It'll do very clever things like help you to understand your remaining useful life of a solution. So where I mentioned earlier how you may be scheduling your maintenance of your devices when you don't necessarily know whether they're actually towards the end of life or not, you're just maintaining them to make sure they continue to run. This will actually give you now a very good indication as to at what time it's expected to fail. And it isn't a case of it's going to fail in the next hour, it's a case of it's going to fail in the next couple of weeks or couple of months, so that you can schedule that into a very strict and stringent maintenance routine to make sure you plan the right downtime and to be able to achieve it. And it'll obviously tell you things like about your asset health, so it'll do like things like health assessments. And this is a view of what the web portal looks like. So it is web-based. It is a cloud-hosted solution. So something that you don't have to worry about receiving the latest updates, very similar to some of our other Wonderware solutions. When you log into the portal, you've always got the very latest algorithms. It's really important that it's that managed solution so that those algorithms can be updated from the supplier on a regular basis. And you can see things like calendars, so you can get a really good idea based on the assets that you've got in your plant as to which ones are going to fail when, so you can schedule that into that maintenance routine, as I mentioned. And you can scale that up, so you can start very, very small and scale up to a very large amount of devices as you want to. And it might be a case that you don't do this on every device in your environment. It might be a case that you do it with particularly problem devices that you've seen, or perhaps it is quite legacy machines that are quite bespoke to your environment now, and you're worried about the life and longevity of it, so it's really important to do this additional tracking on it. But we've seen some really good traction with that. And then very lastly, really the whole thing is built on top of, again, our system platform solution. So you've probably heard this an awful lot. That system platform base that you can see in the middle there, it's that historian really from this side that is really where we're referring to, so being able to analyze all the data that you're storing. And then because it is a platform, it then gives you the ability to bolt additional solutions on top. So it's things like that business process management, it's things like more complex reporting tools or intelligence tools, being able to do things like having everything mobile. Perhaps you do want that MES system to be able to record that quality. This is really where the starting point is. So then just to summarize, hopefully you've seen quite a few interesting ways that you can reduce your operational costs throughout this webinar. I'm more than happy to have a bigger conversation with you if you want to discuss it in more detail. You've probably seen that there's an awful lot of solutions in there. I haven't talked in detail about any of those solutions really. I've just really scratched the surface just to tell you that there's lots of different ways you do it. We address it in many different ways, and again, come and talk to us if you want to. And it's built on our core technology, our system platform. And then those people, processes, and technology are key to making all this work, because you can invest hundreds of thousands of pounds in your technology, but if the people don't buy into it and your processes don't allow you to be able to change and continually improve, then you're not going to see the benefit. You need to make sure the technology decision is right for you and the people are on board before you go there. So we're now going to...
Line unmuted.
And I'd like to ask if there's any questions. Okay. Very quiet audience. So, yeah, I'd just like to then thank you very much for your time. Thanks for joining us today, and we'll see you on another webinar.